Hey guys, so this is the 2011 final, and this is question number 4, the timer systems. Okay, so timer systems are fairly simple. Um, all you're given in the question is exactly what settings you need to set, and then you need to refer to your appendix here, and pretty much set bits or clear bits depending on what settings it occurs inside of the register. So there's built-in systems, and essentially these systems can be configured by putting in certain bits into it. And so, like for the seventh position or the fourth position here, depending if you put a 0 or a 1, it'll activate certain systems. Okay, so each one of these are a time. Each one of these exists in a timer system. Each one of them have a different function to them. Okay, so let's get right into it. So enable the input capture system of the HDS12 timer with the following settings by filling in the empty entries in the registers listed below. See Appendix 1 for the description of the content of these registers. Okay, so this is Appendix 1, right? So the first one we're going to do is TSCR1, that register, and it says enable TCNT and fast timer flags clear, enable IC0, disable TCNT overflow interrupt, and prescaler set to 64, capture the rise the edges on PTO. Okay, so let's see. Sorry, one second. I want to check something to for the prescaler system of 64. Okay, anyways, that's okay. We'll figure that out later. Okay. So the first question, so the first one we see is, okay, let's just start with this TSCR110 TFFCA. Okay? So on our appendix here, so 10 and TFFCA for the same register, we're looking here at, okay, so the description says time enable bit 0 / 1 equals to disable or enable the timer. So if I put a 1 there, it enables the timer. Put a 0, it disables the timer. So I want to enable the timer for this one because TSCR, because it says also the next thing it says enable the fast timer flags clear. So in here, I'll look pretty much in the entire thing. You look through the entire thing, see where you can find the fast timer clear. So here is TFFCA timer fast flag clear all bit. 0 allows timer flag clearing to function normally, and then 1 a read from the input counter or write from an output counter channel clears the corresponding CNF, and access to TCNT clears TOF. Okay, so that's what exactly we want. TCNT and the fast timer flags clear. So we're gonna set TFFCA to 1. So in our question here, TFFCA and the description here says that if I want to enable that, I have to set TFFCA to 1 to get TCNT clears and then TOF, the timer overflow. So that's going to be 1. Okay, and then in order to enable this entire thing, I have to set this 10 to 1. And why that is because if I even want to use this register, I have to set that to 1. If I don't set that to 1, this entire thing is not on, right? It doesn't do anything. Okay? Sorry, one second. Okay. All right. So the next one is, let's see, TIOS. Okay. So TIOS, it says, let's go to the TOS register. It says enable. Sorry, it goes iOS 7 down to 0. Enable capture is 0. Output compare is 1. Channel configuration bits. Okay. So it says enable IC0, right? So 0th position is this one all the way on the end here. That's why this guy is blank here over here in the question. So it says enable input capture, IC, right? Input capture. Okay, so to do input capture, I have to put 0. So I'm going to put a 0 here. Okay, so next, go to the next one. So TSCR2. So in TSCR2, let's look in the instructions here. It says in the question, it says disable TCNT overflow interrupt and prescaler set to 64. Okay, so let's see. So I want to disable TCNT overflow interrupt. So the full TOI overflow interrupt enable bit is 0. So enable is 1 and disable is 0. So I want to disable it. So I'm going to put a 0 in TCR2. So I'm going to disable it. Okay? And then I'm going to set the prescaler to 64. When you want to set the prescaler to 64, you want to set these three guys to the binary of 6, because inside of here, the prescaler, what it does is it does 2 to the power of whatever you set here. So if I set 1, it'll do 2 to the power of 1. If I set 2 in binary, it'll go 2 to the power of 2, which becomes 4, right? So if I do 6, 2 to the power of 6 is 64. So in 6 in binary is 1, 1, 0, right? Which is 2 to the power of 6 equals to 64. Okay? So when I set the prescaler to 6 in binary, that's how I get to the power 6. Okay, so we disable the timer flow interrupt, and we're going to set it to prescaler 64. So it's going to be 1, 1, 0. Okay, so the next thing we need to do is TCTL4. Okay, so let's look at that register. So it says these are the settings. So each of them have different channels. This is channel 3, this is channel 2, channel 1, and channel 0, right? So for each, this is EDG NB. So N means any channel, whichever channel you choose, and it says edge configuration. So 0, 0 means capture disabled, 0, 1 means capture on the rising edge only, 1, 0 capture on the falling edges, 1, 1 means capture on both edges. So the question asks us capture on rising edges of PT0, which means channel 0. So channel 0 is going to be the bottom two over here, and we wanted to find rising edges. So rising edges settings is 0, 1. Okay, so in this register in the question, it's going to become 0 and 1. Okay, okay, so now we have our registers filled. What we're going to do now is we're going to complete the following programming, right? So essentially what this is this is the programming that you need to know to set up these registers, right? Essentially what you're just going to be doing is you're going to be moving the bytes, and if it's all 0, you can be clearing all the bytes. You're going to move the bytes into the whatever each the respective registers, and you're also going to clear all the bits if everything's clear. So in the first one, TSCR1, which is here, we want to put in the hex form of 1001 and 000. So we obviously know that the rightmost one is going to be 0 because the last 4 is 0. And bringing up my old conversion chart here, I had it written down here. Yep. Here we want 1001. So let's find it on the thing. 1001, which is 9. Okay. So let me verify that. Yep. Okay. And so the next one is be clear. That means byte clear. And what it does is it clears the bits in the memory, and it does an AND operation with a mask. Okay. So remember how we had branch clear? It would compare it to a mask, and then the operand would be compared to the test, which is TIOS, would be compared to a branch, or a mask. So in this case, let's see, just a little bit of. So if I have my testers, I want TOS is all zeros, right? I want them all to be 0. Okay, so what be clear does is that regardless of what is inside of TO 1, 2, 3, 4, 5, 6, 7, 8, so TIOS. So regardless of what's inside of TIOS, right? If I put a mask of FF, which means 1, 1, 1, 1, 1, 1, 1, 1, right? If I put a mask like that and I clear it, what happens is BR clear, what it actually does is it takes the operand, so it takes the memory. So the syntax in your instruction sheet will look like this: m dot mm not. So that means it's gonna not the means mm means memory mask, m means memory, which one you're testing. Okay, so the memory that we're testing is TIOS, and the memory mask is FF, right? Because we want to clear everything. So what it does is not FF, it goes 0, 0, 0, 0, 0, and anything inside of here that is 1 or a 0 will be cleared. So 0 and 0 or 1 will always be what? 0, right? So it'll clear everything. So everything will become 0. So everything in the end, if we do B clear, BCLR, TIOS, comma, $FF, if we use the mask $FF on TIOS, it'll clear everything, regardless of what happens. Just refer to this model, because this will be knotted, which becomes 0, 0, 0, 0, 0. Everything becomes 0, because this is the mask, and it's the knot of the mask, and it becomes a logical AND, which is 0 dot whatever the hell this is inside of TIOS, and it always becomes 0. Okay, so that's why we do $FF. And we need to put a pound because it's the value of this. We actually want to do this, not the memory address of FF, the actual value FF. Okay? Okay, good. So going on to the second one, we're going to move byte. And the reason why we're going to use move byte in this case is because we have certain places that have a 1 in there, and we're not going to clear it all. So just be clear. Be a byte clear is just a very convenient way to clear off an entire register. Okay, just keep that in mind for your programming. But move B, pound $, which is the value that we want to put, and then this is our source, and we're going to put it into this destination, right? The destination is the register, the source is whatever we want to set. So going back to the register here, it's 0, 0, 0, 0. So the first part is 0, the first 4 is 0, and going back again to our conversion table, we need to find out what 0110 is, and I believe that was 6. Yep, so 6 here, 0110 is 6, so we're going to put 6. Because we want to, obviously we want to set the first one to disable the TCN tool and the prescaler of 64. And remember, this is 6, so 2 to the power of 6 is what? 64. Okay, so move B, move byte for the last register. You can obviously already tell it's going to be 0, 0, 0, and then there's going to be a 1 at the end. So we're just going to put a 0 and a 1. Okay, and that's question 4. So let me know if you have any questions. It's really as simple. If you're confused on how I got any of these things, just refer to your appendix and just do the settings. It's essentially just an instruction set for settings. That's it. Okay, all right. Have a good day.